So for the naming of the alcohol or alkanols, the one that we daily life used quite a lot is ethanol, which is C2H5 and then with an OH. So in fact, it is very similar to the name of ethane. So let's see what make it happens for the systematic name, the IUPAC name. Now, first of all, we have the ethane, it is C2H6. And then if we substitute one of the hydrogen to becomes an OH group, in fact, the properties will be changed. Now, that is, we will change to becomes OL because alkano, OL is at the end. While we eliminate the E and then further connecting with each other, it will becomes ethanol. So the naming of alkanols. Alkanols have the general formula of CnH2n plus 1 OH, or simply the ROH, whereas the R will be the alkyl group, that is the hydrocarbons only. While the functional group that's present will be the hydroxyl group, the OH group. So the name of the functional group is hydroxyl group, while the writing should be hyphen OH. Well, we need to find the longest continuous carbon chain containing the hydroxyl group, OH group, that is the parent chain, that is the root. Well, we just need to change the last letter E of the name and then change to OL. So we omit the E and then change to OL, then it will be alkano. So that's why we have methanol or methanol. Starting the word methane, we omit the E and then OL, methanol, methanol. Or starting with two carbons, ethane, originally, we omit the word E, the alphabet E, and then add OL, then it will be ethanol or ethanol. So the suffix, we will add OL, and then if it is a long carbon chain, for example, 3 or more carbon atoms in the chain, we need to add the numeral to label the position of the OH group in the chain. So that's why we have propane 1O. So starting with 3 carbons, because the OH group may be on the second carbon, that is propane 2O. So we will label the upper one, the first one will be propane 1O, but not the propane 3O, because we need to label the lowest possible numeral to the OH group. So propane 1O instead of propane 2O. While if the OH group placing in the middle carbon, it will be propane 2O. While if we have a methyl group attached to the second carbon as well, it will be methyl propane 2O. So this is the substituent, and then it must be appears on the second carbon. If it is placed on the 1 or 3, it will become butane. So it is methyl propane 1O. The methyl group must be on the second carbon. So we don't need to write 2 methyl propane 2O. So with such understanding, this one, the longest carbon chain will be 4 carbons. As a result, it is butane. And then the second carbon will have the OH group. So it is butane 2O. Now, don't forget, we have to label the functional group, that is the root, as smallest as possible first. We don't need to think about the prefix, that is the substituent. So the bromo group is the assigning for the numbers of the bromo group. It's according to what we have assigned for the OH group. If this is assigned as the second carbon, then the bromo group will be the fourth carbon, and the methyl group will be the third carbon. So we assign 4 bromo, 3 methyl. Bromo are placed in the name first because B is in front of the M in the alphabetical order. So 4 bromo, 3 methyl, butane 2O. So naming alkanos with more than 1 hydroxyl group. But the point is, in fact, if there is more than 1 hydroxyl group, we will not say it is alkanos anymore. Instead, we will say this is organic compounds. If we name for the organic compounds with more than 1 hydroxyl group, so find the longest carbon chain, again, containing the maximum number of hydroxyl groups, and then add the word diol or triol to the suffix. So also we need to add numerical values or the numerals before the suffix to indicate the position of the hydroxyl groups as well. So that's why we will not say alkanols anymore. In fact, you may use the word organic compounds or alkanol. So some of the examples is here. If we have 3 carbons and then with 2 hydroxyl groups on the hydrocarbons here, originally it is hydrocarbons but substitute with 2 OH group, we will say this is diol. While the position for the diol is happened on 1 and 2, as a result, it is propane. And then we don't need to omit the E now. We just continue propane 1,2-diol. Or for this one, it is propane 1,2,3-diol. The word E in the alkanes originally retained, and then it will become diol and triol. That is, the E is retained. As a result, don't omit the E. If it is propanol or propanol, we need to omit E. But if it is diol or triol, we don't need to omit the E. We need to get back the E here. So naming organic compounds alkenols, that is with CC double bond and or hydroxyl group. Now, some organic compounds containing both carbon-carbon double bonds and then hydroxyl group. So we say that it contains CC double bond, so it is in. While the OH group also co-presence, that is O, OL, O. So the final suffix will be enol. And this one, we say that it is built 3-in-1-ol. Now, because OH group here is the major functional group, so we label it first as 1, while CC double bond will be labeled as 3. So for this one, it should be butane-1-ol, and the upper one, we will say it is pro-2-in-1-ol. So enol, we need to label the functional groups, the position of the functional groups correspondingly. So once we change this one, add 1 more to be bromo, because the third carbon is here, CC double bond is here, the third carbon, and then this will be the 4th carbon. As a result, the naming changed to becomes 4-bromo-butyl-3-in-1-ol. Now, the problem is why we assigned OH as 1, but not CC double bond as 1. That is, for example, for the one that we have in butyl 3-in-1-ol as well. So why we need to assign OH group, and it is as 1 at the first carbon, but not CC double bond at the first carbon, so that bromo will be 1 as well. Now, just because OH group is more reactive than the CC double bond, there should be more reaction, and it also affects most of the physical properties. Once the OH bond presence, it will affect the intermolecular force, which is hydrogen bonds, which we will learn later. So for this one, as it affects most of the physical and chemical property for the hydroxyl group, so it is more important to label it as 1. So we say that this is the more important functional group. As a result, we label it as 1. So that's why it is butyl 3-in-1-ol or 4-bromo-butyl 3-in-1-ol now, but not 1-bromo-butyl 1-in-4. So we should label the OH group as smallest as possible first. So that's why you can do this class practice. You may pause it for a while and then do it. I will show you the answer here. So here is the answer. So let's check for your understanding here. The next one. So for the next one, you may pause it and then think about it. Now for the one that we have here, propane 1,2-diol will be, sorry, this is propane 1,2-diol, but not ethane. So this one has to be changed. This is propane 1,2-diol. While the next one, this one will be propene, but we need to label it pro-2-in-1-ol. So this is pro-2-in-1-ol, in fact. So that's the end of this part.